Um, Welcome to the day before 4th of July, but I wanted to take the opportunity now to say happy 4th of July weekend. Hope everyone has, as they say in California, with all of our fun fireworks restrictions, have a safe and sane 4th of July. um, so we'll get started with the last of our scheduled lunch and learns. Not that we won't have some more, but today we're going to go over S1000D applicability. So what is applicability? We'll start to define all the bits and pieces of it, and hopefully at the end you'll have some ideas what all this craziness is with our ability to um, um, get applicability working with understanding some of the nuances of all the technical terms and how it operates. All right. So a little bit of history on the applicability. What was happening with S1000D when I joined way back when it was issue 2.1, 2.2, right in there, very early 2000s. But the the impetus for why the applicability is today the way that it is because when civil aviation came along, we've been producing documents that contain pretty specific set of information, what we call a configured document. So it was very pointed in terms of this manual has been configured for this airline with these aircraft, and that's the only view of that data um, that gets produced. So for a number of years, for a long time, we have been building software solutions at the OEMs to be able to do this configured document. And then when civil aviation came along to S1000D, we looked at the applicability model and went, ooh, this doesn't work for us. And we need to provide these configured and customized manuals for us to even consider using S1000D. So something had to change, um, and um, so that's kind of why applicability is the way it is today. Um, and why we decided to do this applicability model again is just kind of support our dislike for um, the one that was in S1000 at the time. It was originally designed to support paper publishing, and little had changed over the previous 25 years of S1000D and what have you. So it lacked a lot of flexibility that we wanted. um, to do the things that we need to do, or to allow other industries to start using S1000D and start calling the things that they want to support with applicability, give it their own names and attributes and what have you. And we'll get into that. But it lacked this flexibility of being able to not being able to process these applicability statements. So there was no standard way for a computer to read that and then interpret that to provide the customized or configured view of that data. Um, and we knew that if we're going to go and change the applicability model, let's go and swing for the fences. And so let's really try to standardize the way that we will be able to interpret statements by different software tools to do exactly the same thing every single time. Because I was working at Boeing at the time on the 787 program, and so there was a lot of influences by how Boeing over the years have been doing configured and customized documentation, McDonnell Douglas, Bombardier, Airbus, what have you. And we wanted to make sure that this new model fit the publishing expectations of all these different OEMs. Um, so we knew what we wanted to do, what was desired, and we needed a method to accurately and consistently process applicability by software tools, therefore giving viewers and CSDB software vendors the opportunity to build tools to do these things. Basically, what we want to do is allow filtering of data during publishing and IETP runtime. So either filter it prior to it going to a customer, or being able to do it in real time at the point of use. Um, and we want to be able to promote data exchange and reusability of these different applicability statements, because we found that um, hidden behind the scenes at Airbuses and Boeings and all those, we had our own ways of reusing applicability statements so that writers didn't have to memorize the very complex Boolean expressions necessary to build these statements. So we always worked on ways of like, here, let me build one for you, and then that will manage. That will always be the case when you when you have this expected output. And we needed the flexibility in S1000D Plic so that different programs can define your own applicability attributes that affect their data. So call things what you want to call them, no matter what industry you're in, whether you're in military, aviation versus civil aviation. We may have different terms. The fact that Navy and boats and Coast Guard, well, they don't have a fuselage number. So why are we having an attribute called fuselage number? That makes no sense when you're trying to deal with a hull number, right? So we wanted that flexibility of like, no matter what industry you're in, you're going to be able to define your own applicability attributes that suit your business. All right. So this is kind of what the applicability looked like during through the years. It was very, very basic in issue 2.2. It was display only. You couldn't do anything with it. You just would look at it and go, does this apply to the thing I'm working on, yes or no? So issue 2.3 came along, and this is when civil aviation decided, well, let's model, let's take applicability, enhance it based on this real basic model. We needed to manage things like service bulletins and aircraft, what we call aircraft tables, which are this customer has this serial number, which has this configuration with service bulletins incorporated. And so we tried to enhance that a little bit. It was actually Airbus at the time that was doing this, and we really took a look at it and went, that still doesn't get us to where we want to be. So that at issue 3.0, we decided to completely rewrite the applicability model, kind of scrap everything that was in 2.2 and 2.3, and develop a model with more generality to it to have it to what it does today. So if you had a time machine and went backwards at my time at Boeing, we ended up a team of 4 or 5 of us in a conference room for about 4 months, and our walls actually were made out of this whiteboard material, and all 4 walls were filled with ideas, and to come up with the applicability model that it is today. That's part of the reason why I'm pretty intimately familiar with how all this stuff works, because I was on the team that developed this model for S1000D. So it was a big, huge effort. Pretty proud of what we were able to accomplish, because it does some pretty powerful things, and to do some stuff in the industry that we hadn't been able to do before. So and have it apply to everybody, which is really our goal. So a little good to know. I like to think of applicability as the condition where the data is appropriate. It is not the configuration of the product. Okay, so it doesn't say, oh, this is the current state of your product, or your aircraft or your Jeep or your what have you. It is saying that this data is appropriate given the conditions that you've put into, say, an IETP at runtime. Applicability can consist of product configuration attributes. We can also do things with testing results or fault codes with advanced systems, or we can do environmental conditions. And all those that basically have an effect of whether the data is applicable, we can build into the S1000D applicability. So here are two terms that I need everyone to fully understand before we can go forward. And these two terms are product and product instance. This is the basis of which the premise in which we developed the applicability model to, okay? So a product is any type of vehicle or equipment, and I don't care what it is. It's an aircraft, a submarine, a ship, a tank, a Jeep, an oil rig, anything you can think of. So it could be a car, right? So think of the analogy of a car. So we have a thing called a car, all right? And then we have this product instance, which is a specific serial number of a product. So in this case, the product is aircraft. The product instance is manufacturing serial number of a Boeing 787. Its serial number is 36400. So that's a certain instance of that product. But it could be your car, right? So your car is a Mazda CX-9, and it is of a particular VIN, right? So it may be the LX model and it has all these bells and whistles. It's got the backup camera in it. It's got, all the, Cirrus radio configuration. It's got the new, high output twin turbo, blah, 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 right? So that's the instance of that Mazda CX-9, which is the product, right? So product instance. So if you can follow that sort of notion, you'll have an easy time with understanding the S1000D stuff. All right, so product instance, very important as we move forward. Because now what we're going to do is we're going to dissect the different parts of applicability, and there are 3 specific data module types that we have. All right, so these are written in XML. They are stored in a CSDB. They are edited by usually 1 or 2 people that understand the applicability data module types. And it's under configuration management. So these different data module types, they have different schemas, and they are the terms ACT, CCT, and PCT. And we'll go into each one of these in some detail now. So ACT, what is it? Well, it's called the applicability cross-reference table, and it's used to declare product attributes. Remember I said product and product instance is very important in terms of your understanding of S1000D, and this whole idea of this applicability stuff. So it's where we're going to and the reason why we have the ACT is provide that flexibility that I told you of, right? So normally these product attributes, typically they don't change over the lives of the product. So things like model. So you're defining the fact that this project is going to use a product attribute called model or serial number or fuselage number or hull number or VIN number, right? Any of those things you can define to your project. And the reason why we did this is to create that flexibility. So if we were working on a ship project, we don't have serial number or fuselage number. We have hull number. So we want to be able to define our product attributes based around things that do with ships. So our ACT will be filled of product attributes that have to do with the shipping industry, not something not some generic term that everyone has to interpret that as being a product attribute. So this is that flexibility that I was speaking to. All right. So next is the CCT. And these are where we declare technical, operational, or environmental conditions. All right. And so an example of those three are maybe there's a technical condition like a service bulletin or TCTO or any sort of engineering modification. Those are a technical condition. We have operational examples like regulatory rules like ETOPS, right? ETOPS is for extended range of a two-engined aircraft over water, right? Or maybe location for maintenance. Maybe in order to perform a certain piece of maintenance, the aircraft has to be in a hangar, or the ship has to be in dry dock, something like that. So there's an operational example like that, and then we have environmental things like wind speed, heat, high altitude, sandy conditions, any of these environmental type things. Do this only if the wind speed is less than 30 knots per hour or something like that. So there's these technical conditions that have an effect on data that we will declare in our CCT. And I'm using the word declaring because the ACT and CCT are the place to where we define these things. We define product attributes. We define technical conditions. Okay. And then the last piece, all right, the product cross-reference table, or the PCT, this is where we pull all of those things together. We pull in product attributes, we pull in technical conditions, and this is where we define product instances, right? So we take different specific values from product and condition expressions that are in the ACT and CCT, and we formalize them into product instances and the configuration of each product instance. Okay, so this is where we declare that a particular aircraft with a serial number and which is made up of a make and a model, okay, also has service bulletin something installed. And so that's the product instance. So this is where we can formally define that configuration of each instance and define what it is. Okay. So that's the PCT. So this is the thing that brings it all together. All right. And this is, I'll save that comment for later on. But really, and you've heard me say this before about product definitions, the ACT, PCT, and CCT are really defining the product, right? And all the different pieces and attributes that go with it. All right. So all these things must work together. You can't have one without the other. You can have a project that doesn't have a PCT. That's not necessary. If you aren't interested in sort of this real-time product configuration, the only thing that it does need is an ACT and then CCT if you have them. Anyway, so that's how all the different things come together to create the product definition, and really is the formalization of applicability. Any questions up until this point? Hopefully it's kind of clear. If not, I'll carry on. So let's get into the different moving parts now, kind of getting down into the XML and sort of explaining the different parts of these data module types. So first we start with defining product attributes. That's always where we start. And so product attribute has to have these things in the PCT. So first we have an ID, so we give it a unique identifier. And we're going to use this ID later on in what we call applicability annotations. That's the stuff that goes inside of S1000D data modules, procedural and descriptive and all the other ones. So that ID is pretty key into us calling those things into our data modules later on. And it needs a name and a description, and it also has a list of possible values or value patterns, and that's that enumeration down there. It's optional, but a lot of people like to put those things in there. All right, so that's by the schema. That's what's necessary. And then I have an example of what a product attribute list would look like inside of the PCT. So this first one, you'll see that we have a product attribute. It's called a serial number. All right, and that's just open text. There's no enumerated value that is being set there. So we have this thing called serial number. All right, so this is where we're declaring that this project will use an attribute, a product attribute called serial number. The next one here is model. All right, so and then we do have an enumeration on this that says that this is the only model that you're allowed to use. All right, so we define what that value is, and we enumerate it, and so it's pretty straightforward. So now we have a serial number that can be open. You can type in any serial number, but it's got to be based on this model. So BKTRK, which in S1000D bike example land, that means a Brook Trekker mountain bike. Anyway, the next PCT entry that we have a thing called a series, and it is also numerated. And this series only has 3 allowed values. So that tilde is a range. So 1 through 3 is the only series number allowed on the project. And then the third example here, or fourth example we have a frame type. Okay, and frame type is gives you 2 values, either steel or an aluminum frame. So you get to choose which one that is. All right, does that make sense? Again, these are pretty static. These things don't change. You know, the fact that we have serial numbers and model numbers and you know, we may add a frame. Maybe, you know, one day we may add, you know, carbon to this. I don't know. But these typically don't change. We know them right away from when we have projects start. So PCT is pretty easy to put together. So, all right. So once we're done with the PCT and declaring all of our product attributes, we get to go to the CCT and start defining these things, so the conditions that we have. And there are 3 major parts to the CCT, and we'll break these down into each one. First, we have a condition type list, and that is to have the ability to define common types of conditions. And then we have condition list. This is where then we will actually list all of our conditions. So so the condition type list says that you know, we have a thing called a service bulletin, and then the condition list will say, well, I have 5 service bulletins, and I'm going to list all 5 of those and define what those are. And then you have an optional thing at the end called incorporation status. So that is our ability to transmit to our data receivers the fact that these conditions have been incorporated somewhere in your technical documentation, and it's optional. So there's not a lot of projects that use that anymore, but it had to be there for civil aviation purposes. All right, so let's dive into the condition type lists. and define what those are. So the previous one is all three sections within the CCT. Now we're going to break those down into each section. So condition type. So here's where we're going to define our condition types. Again, needs a mandatory identifier, an ID, needs a name and a description, and also, again, a list of possible values or value patterns with enumeration at the end. All right, so at least 3 out of those 4 are mandatory, with the enumeration being optional. And this is what the XML would look like if you actually looked at the CCT. So we have a condition list. In this case, we have 2 condition types. One is a service bulletin, and another condition type is a TCTO, or a time compliance technical order. All right. So this is the part of the CCT that just simply declares the fact that we have a thing called a SB and a thing called a TCTO. We're not actually saying, that these things apply to a particular aircraft or ship or tank. It's just saying that, hey, we have this thing called a service bulletin out there, and we have an enumeration that says, well, we can either be pre-service bulletin or post-service bulletin. Those are the only 2 values that we'll be able to use on this condition type. On TCTOs, we're giving a value of either true or false. Either it is or it isn't. All right. So that's this thing called a condition type list. Any questions on that so far? So it's, again, just inside the CCT, we're just saying, hey, I got these things called SBs and TCTOs. And then we're going to use that later here in a minute. And the whole thing is based on this ID. And you'll see here in a sec. So now we go to the condition list. All right. So condition list is each instance of a condition. So again, we have a mandatory identifier, and this identifier will be used inside of applicability annotations later inside of data modules. We're not there yet. But if a writer needs to say, well, I'm writing something that is pre-service bulletin XYZ, they'll will identify that block of text with a applicability statement with an ID on it, and it's this unique identifier that we will use. Now, this is where we tie them together. So a type reference, or condition type ref ID, makes the link to a condition typed in the condition type list. So remember that previous section of the CCT, we said we have a thing called a service bulletin, we have a thing called a TCTO. What I'm doing now is saying that this condition is of type TCTO or is of type SB. And we do that by referring to the ID of this thing for SB or TCTO. Okay, so that's what would go into condition type ref ID, because we want to say, oh, this is a service bulletin. And then what we do is we add a name and description. So here and here. And we also can link to the actual publication itself by using this refs, which is optional. But what you could do is if you're in an IETP and you could store all those service bulletins and TCTOs in your IETP, and you can link to them from the data. So you can say, oh, does this apply, yes or no? And you can also take the mechanic off to go actually look at that and have it stored that way. That was just an optional thing to do to allow you to link to that actual thing. All right. So that's how that works. And then we have this little fun fact that sometimes might be useful. So we have a thing called a prompt, and that's used to contain text that could be used to create a dialog box. So we may prompt somebody when a certain condition might be encountered in the text. So that's kind of interesting, as well as dependency. And this could be widely used in a lot of areas where it's used to define a condition that is dependent on the existence of another condition. So we may be dependent upon a certain service bulletin that also is dependent on the incorporation of this other service bulletin. And so we can use dependencies to create those links back and forth to each other. Okay. Again, those are optional. They're not, you don't need them. Again, all you need is ID, condition type ID, a name, and a description. These are all other optional things if you decide to use them in your project. And so what a condition list looks like, well, this is what it is. So remember, I told you there's a condition type, and this is the ID. So it says, well, this ID is Service Bulletin S1001. It's of condition type called SB. Okay. Here's its name, its description. This is what it does. It installs the a chain guard on, because the bike didn't come without a chain guard, and we decided to issue a service bulletin to install that chain guard. And this is where I also threw in the dependency, right? That it's going to test for this ID of A1, and it must equal post of that value for A1. So you can't install SB's S001 until this has been accomplished, right? So that's how we kind of drive display of and enforcement of certain things within the data. Okay. So here's some more condition lists. Again, we have we have brakes, we have headlights, we have chain guards, we have condition IDs, and we just continue to build this list of things. So the sort of middle section, if you will, if you kind of think of the CCT in segments, we have the condition types, we have the list. So this list section is a continual thing. This will be updated as long as you're doing service bulletins and TCTOs and mods. You're always going to be adding to the condition list. So that is of all the applicability. You know, this is pretty active. Again, the ACT, not so much. You define a bunch of stuff and you're done. The CCT and the condition list, you're always updating as new conditions come along. Okay. And then we can do this cross-reference table to cross-reference the incorporation of documentation that says, you know, these conditions have been implemented and where. I won't go into any real detail here because not a lot of people use it, but just wanted to show it anyway, just for reference. So that's the third section of the CCT. All right. Any questions on the CCT? I know I'm going really fast, but there's a lot of stuff with applicability that I want to make sure that I covered at least throughout our time here. So, all right. Next, the PCT. And again, this is where that idea of product instance comes up. So the PCT data module is used to declare individual product instances that are covered in the CACB. and each individual product instance is defined by several product attributes and conditions. Again, this PCT relies on the CCT and the ACT to bring together these assignments of product instances. So to build this thing up. And this is what it looks like. The PCT has one or more products with one or more things called assign, and that's it. That's all we do is we continually adding a product with a bunch of assignments, and we're taking values out of ACT and CCT to assign them to a particular product instance. All right. So how do we do that? Well, the assign has a thing called product attributes and has an ID that we'll take out of the ACT. Or we can take a condition and that ID out of the CCT. Okay. All right. We have a property type, which indicates what type of thing it is, whether it's a product or a condition attribute. And then this is where we're able to assign product attributes or conditions. All right. So I know that looks a little confusing, and probably the XML looks a little bit better. So we have a product instance, so product here, and we're going to assign 4 values to it to make up this thing. All right. So we're gonna take the thing as something called the serial number, and we got that out of the ACT. It is a product attribute, and here's its value. So a serial number is 1B070643. That's it. Pretty simple. Remember, because serial number was open, right? So we can type in anything we wanted here. All right. So next we have model. Model we get out of the ACT, which is a product attribute definition, and we use the value called Huffy. All right, so now we've associated model with Huffy, serial number with this number. We're now going to assign another ACT value called version, and here's its value. It's a product attribute. And last but not least, we're going to take something out of the CCT, which is a condition. Okay, it's of type condition. I can find this ID called Service Bulletin S001. And for this product instance, we have not incorporated this service bulletin yet. So it's going to have the value of pre. And that is very simply how you build a PCT. You take all the different product attributes, all the different condition values, and we're going to say this now makes up a bike, one bike. It's got wheels and a frame. It's a model number, Huffy. It does not have a chain guard yet because it says pre. We have not done that work yet. And then that is how ITPs work in saying, oh, what are you working on? I'm working on this model number. It interrogates the PCT and goes, oh, guess what? We have found the fact that this chain guard's not been installed yet. And I will give you information based on what to do on that bike without the chain guard installed. Does that make sense? I'm hoping it does. Maybe some virtual nods.
Yeah.
So this product cross-reference table is continually updated as OEMs continue to deliver aircraft or Jeeps or tanks or missiles or whatever, and they send this data to their customers. This gets updated all the time. Not only that, but this is where the coolness happens is customers can take this PCT and tie that to a maintenance system, okay? because they typically have maintenance systems at airlines and the military, and says when a guy goes and does something, he'll go put it inside of his maintenance system and says, oh, I've incorporated this TCTO. Right? And so he'll go in and, yep, I'm done with my shift. I did this TCTO. And then overnight, that maintenance system can go back into the PCT and update from pre to post now, because the maintenance system updated the current, what we call the as maintained view of that product, is almost happening in real time. So on the next shift, when somebody goes out and tries to perform maintenance on that piece of equipment, he'll know that this is now changed to post, and he'll get information based on the fact that the change guard has been installed at a snap of a finger. So we've provided industry now with this whole idea of this applicability model to update technical data in near real time, okay, of the what we call the as maintained configuration. We never had control over that. We were always relying on our customers to say, oh, yeah, I've put all those service bulletins, and here's the status of my fleet, and I'll give you some sort of a record that I've done that work. So next time you give me my technical documentation, please make sure that you've updated my fleet view of the current status of those SBs. And it was a forever. It's been problematic in this business for a long time that we weren't able to truly reflect the as maintained view of the aircraft or the thing, the product, and the technical data. Now we're able to do that. And this is kind of what's exciting about this whole model, is that we've given technical data almost near real-time freshness as to the real configuration that our customers have for these products. So serviceability goes up, right? Because now the data is truly reflecting that configuration of the product. All right. So how does all this stuff happen? We have the ACT, CCT, and PCT data modules. Each contain, the information that they need. So at the very top is the ACT, and we have the way of referencing the CCT and PCT that's going to be used in the ACT. And then we also have a way to cross-reference back to the ACT from each one of those. Okay, so that's how we connect the dots between those three different product definition XML files. Is the ACT says, oh, I'm declaring all the product attributes. What's your PCT and what's your CCT I'm going to use in order to make all this stuff work? And so we simply have a ref to those DMs based on the data module code, and vice versa. All right. So that's one half. So then what happens next? Well, we have to have a way, now that we have all those linked, well, we have to link all of our data modules now to this product definition set, the ACT, PCT, and CCT. So what we do is we simply make a DM reference to the ACT, which then has links to the CCT and PCT, and now we're complete. So that's the complete picture. So any expressions that we put inside of data modules will be based on this link and these links here. And the CSDB maintains all that stuff. You don't ever have to worry about it. We put this stuff in ID status ahead of time in templates and all that other stuff. And you just don't even see it. It's transparent to most end users, writers, what have you. All right. So that's how we link DMs to the product definition. So again, all this is happening up until now outside the data module. So when a writer goes in and says, oh, well, I need to put in applicability, what do I do now? Well, that's our next part. to be able to do applicability annotations, right? And these annotations, or applics, as we like to call them for short, has two parts. One part is designed for human readability, and the next part is for computability. All right. So we have a branch in applic called display text. All right. And display text is for legacy, pretty much. It's for the old days that says, on aircraft 1 through 10. And they simply just typed it, and then that was it. And they don't want to, or they don't have the ability to be able to compute these things or that output. So they simply just type it, and it's legacy. So the end user is pretty comfortable with, yeah, I just know what to do there. I just read it and double check everything, and off I go. This computability branch allows software to take these, what we call asserts and evaluates, and to be able to come up with and process the right either display text and or just display based on these rules that you're going to build into this branch called assert and evaluate. All right. So display text is a human readable text of the what we call resolved or static result of an applicability statement on aircraft 1 through 10. All right. This branch down here, we have two things. We have an assert, and it defines a test to either be true or false. Either I conform to that or I don't. And an evaluate are ways of stringing asserts together with operators and or. So you could put things in like on aircraft 1 and service bulletin 1, 2, 3 equals post. So that's how you would sort of string those things together, using values out of the ACT and CCT to build these expressions, all right, or annotations. And probably simpler when you look at it from a XML perspective. All right, so you have an assert here that I'm taking serial number out of the ACT. It's a product attribute, and this is the values. So all an IETP or publishing system would need is this applic statement with this simple assert, and it would know what to do. We also have this thing called display text. This is the human readable thing that says serial number 200 through 350. This is what humans read. They can't determine what all this other mess means. So we use display text to display the human readable side of that expression. All right. So that's a real simple applic statement. Here's one that's a little bit more complex, but it's not too bad. So we have an applic. We have 3 asserts here. We're going to take model, series, and serial number, which are all product attributes that we get out of the ACT, and we take the value that we want for this particular expression, and we string them together with and. So this means, okay, that it must meet this and this and this in order to be true. Remember that this gives us either true or false. It's pretty simple output. So with the human readable side of this thing would say, well, if I'm working on model brick tracker serial number 200 through 350, I know that this data applies to me. And that's pretty pretty straightforward. All right. So next, we have a little more complex one where we're going to string together some ors or some ands. All right. And so this outer evaluate, okay, so these are kind of nested. So what I did was kind of colorize this little thing that says this or is for is nested. We have some nested evaluates that are strung together with ands here. All right. So it means that serial number and breaks, this and this, so these are ands, so must meet that condition and that condition. So that product attribute with that condition, or this product attribute of 1 through 20 with this condition of Shimano. Creates this statement. Serial numbers 1 through 10 with these breaks, or 1 through 20 with Shimano brakes. So as long as your thing that you're working on meets this criteria, well, then that data applies to you. Now you're probably wondering, how in the heck am I going to have to type all this stuff in? Although I don't have examples of it today, we provide you on the software side some luxuries into one, not having to type these things every time. We can build a pool of these expressions for you, and so we can have like an applicability expert that kind of understands this, knows how the software works, knows how all the interaction between the ACT, PCT, and CCT works, and can build these expressions for you. So simply all you have to do is just do an insert applic, find the one that you want out of a pool, select it, and plunk, it comes inside with all this stuff built for you. And then from an administrative side, I've worked on tools that are much like Visio. So you create boxes and arrows to create these ands and ors and bring in values inside those boxes to build these expressions underneath. Basically, so you create it visually, and then you the tool underneath creates all this XML gobbledygook for you, which is kind of nice. So there's different ways that different software vendors provide some applicability, authoring, and maintenance. So that's kind of how the applicability annotations come together with assert and evaluates with ands and ors. So the next level is kind of understanding, well, when you're inside of a data module, what happens next? And so we have two types of applicability. We have, and the first part is data module level applicability. So what we mean by that is that applicability that's up in ID status is applicable to the entire data module. In other words, that must meet that criteria in order to be applicable to that end user. So it's for the whole data module and always applies to all parts of the content. So no matter what, when you declare data module level applic, that applies to the entire set of content, right? And you have to be somewhat careful because we can do what we call content level applicability, but anything that you put inside of there, inside of the content level, better be, right, within the bounds of this data module applic. In other words, if I've said that this data module is good for serial number 1 through 10, okay, and I come down here in the content section and I say, oh, this sentence right here or this step or paragraph is good for serial number 11. Nope, that does not work and is not allowed, right? So your content level applicability must meet the constraints of data module level applic. So always keep that in mind. All right. So then content level applicability, we have some, again, ID status applic, and then we have kind of what we call factorized or groupings of applicability that we've put together that consolidates these expressions in one area of a DM. So we have this thing right inside the content section called ref applic group, and that allows us to bring in an applicability statement out of the ACT, PCT, and CCT. We can build those expressions and then reuse them over and over within the data module. So we're not writing them at every step. We can use an ID ref mechanism, which is just typical XML, to create references to applic. So we can put applic 1 and applic 2 in here, and we can say, oh, I have steps and paragraphs that need to have this applicability applied to them. So I can use ID ref, and I can say, oh, for this sentence, I want to use applic 1. And then when we publish or the IETP runs, it knows that for that step, this applicability applies. And then the same for this green step here. Oh, I want to use applic 2. We use ID ref of this thing to pull it in and have it apply right here. So that's how that works. So this all comes out of a pool. We can bring in applic annotations and this little grouping at the beginning of the DM, and we just start reusing them using ID ref throughout the procedural steps as necessary. So we don't have to copy and paste all over again. So if I only have 2, I only see 2, and I use ID ref on each of these steps to tie them together. Okay, so that's how that works. I know it's kind of like drinking from a fire hose, but there's a lot to applicability. I wanted to make sure you at least had some of these concepts, down, kind of defining what PCT, ACT, and CCT means, the different pieces, how they're declared, how they're used, how to create some expressions. Hopefully the concept shouldn't be foreign. It's just how it's implemented in S1000D probably looks weird until you kind of get used to it. Any questions? There's got to be applic questions. Either that or you're all ready to have our 4th of July. Hopefully that was, I know it's a whirlwind tour, but hopefully that was good enough. The slides will be available. The recording will be available to go back through at your own leisure and pace. But I at least wanted to get it in on one recording. All right. Well, if there's...
Thanks, Jim.